Hello everyone, welcome to another edition of the iOS Lead Essentials podcast. I'm Mike.
And I'm Kyle.
And in this episode, we'll be answering some questions regarding design patterns.
So first question, what is a design pattern?
Okay, so a design pattern is basically a simple and elegant solution to a recurring problem.
Exactly. So these kind of problems that you're most likely gonna face as a software developer and that have been solved already over and over, and it's been documented on how you can solve those problems effectively.
So basically, you don't reinvent the wheel every single time.
Exactly. Because reinventing the wheel is probably a waste of time, and it's likely that you might end up with suboptimal solutions.
Yes.
So worse solutions.
Yes.
Because like a design pattern captures years and years of experience of many developers.
Exactly.
If you try to recreate it on your own, it might take you years and years and years to end up with an elegant solution such as a design pattern. So the idea is to stand on the shoulder of giants.
That's it, exactly.
You build a solid foundation, and then on top of that, you bring your own contribution. So instead of reinventing the wheel, learn the solid foundation, elegant solutions, and build on top of it.
Yes. And we have a quote by Eric Evans here. And Eric Evans says in Domain-Driven Design, when an experienced developer looking at a domain problem sees a familiar sort of responsibility or a familiar web of relationships, he or she can draw on the memory of how the problem was solved before. What models were tried and which worked? What difficulties arose in implementation and how were they resolved? The trial and error of that earlier experience is suddenly relevant to the new situation. Some of these patterns have been documented and shared, allowing the rest of us to draw on the accumulated experience.
That's it. So design patterns give you elegant solutions to recurring problems. So it helps your code be more flexible, maintainable, decoupled, and all the good traits you want in a software system. And they also give you a vocabulary to talk about those problems.
Exactly. You can communicate with others what the problem is and what solution can be applied to that problem. So this is very important because if I tell you I'm going to use the Decorator pattern to solve this problem, then you instantly can identify and can know what do I mean by that. So there is an effort for eliminating miscommunication there. So that's very, very good, very important as well.
The better your vocabulary, the better you can communicate your intent. You can take these shortcuts of just saying a word like decorator and conveying the meaning instantly to your peers. But both sides need to understand the vocabulary for it to work.
Yes.
Of course.
Yes.
That's why you have design patterns. So a design pattern have a common name. They refer to a specific problem. They provide solutions to that problem with trade-offs and variations of the pattern as well.
Yes, exactly. And as you said before, they are well documented. So all these things are known to anyone who is looking for them.
Exactly. If we share the same vocabulary, we can take shortcuts and achieve better results. So that's it. Next question. Where can I find the best catalog of design patterns? First of all, Wikipedia is not this catalog. You can find all the design patterns in there, but the descriptions are not the best ones. The best catalog that I know is the Design Patterns book.
That's right. By Vlasidis, Helm, Johnson, and Gamma. It is being the Bible for design patterns.
Yes. So if you go to Wikipedia, you're going to be referencing the book. If you read other books that mention design patterns, they're going to be referencing the Design Patterns book.
Yes.
So that's the best catalog. It doesn't mean you need to read that book from cover to cover and memorize every pattern. No. It's important that you understand the basics of the most commonly used patterns. And if you have a problem that you're looking for an elegant solution, you scan the book until you find a pattern that fits your problem. And that's it. The Design Patterns book is the best catalog to date of the design patterns.
Exactly.
Next question. What is an anti-pattern?
Okay.
The opposite of a design pattern.
Right. An anti-pattern is a solution that the industry has deemed too risky and has found better solutions, better options to a specific problem. So basically, it's an option that you should not use because there are better options to use.
Exactly. Every time you use an anti-pattern, you are introducing a liability to the system.
A known liability.
Yes.
A widely known liability.
Because an anti-pattern is only considered an anti-pattern if there is a better alternative. If there are no alternatives and you have a bad solution, well, that's the solution.
Exactly.
Until there is a pattern that solves that in an elegant way. So I have a quote here from the Anti-Patterns book by William J. Brown. An anti-pattern is a commonly occurring solution to a problem which generates decidedly negative consequences, although other documented solutions that prove to be more effective are available. So when there are better alternatives, but a team keeps using a solution with negative consequences, they are using an anti-pattern. For example, overusing globals just for convenience. For example, convenience of accessing an instance, network stack.shared or database stack.shared, and introducing these potential concurrency problems or increasing the complexity of your system because every shared instance now needs to handle multi-threading, or just making global mutable state that can make it very hard to keep data consistency.
Even worse, if this global state is mutable, so you have .shared and you can set it, not just access it, but set it as well.
Yeah, you end up with data races. Then you need to wrap all your code into some kind of queue, which makes things slower and more complex.
Temporal coupling, you don't know what the order is and what is being called when. I mean, it's bad.
And it's an anti-pattern because there are better solutions. Proper dependency injection, for example, separation of concerns. So that's it. Anti-pattern is a commonly used solution with decidedly negative results, although there are better solutions around. Next question. Are all design patterns similar, or are there categories of design patterns? Well, there are design patterns that are similar to others, but not every design pattern is similar.
Right.
So, yes, there are categories of design patterns. For example, there are structural design patterns, like the Decorator pattern, the Adapter pattern, the Composite pattern, or even architectural patterns, like MVC, MVVM, and MVP. They are also structural patterns. They help you structure your code.
Right.
And if you're interested in MVC, MVM, MVP, we already released a podcast dedicated just to those patterns. So we're not going to mention them today. So that's structural design patterns.
Yes. And you have also creational patterns, such as the builder pattern and the factory method and the prototype, which are all about how you create your objects.
So even Singleton is a creational pattern because it's a pattern on how to create and manage the instance of your objects.
Yes, exactly. And finally, you have behavioral design patterns, such as the chain of responsibility, the observer, the strategy pattern.
So design patterns that solve similar problems, they are part of the same category.
Yes.
And some design patterns might even cross categories, but they have like a main category. And all of this is documented in the design patterns book. And categories are just a way of helping us organize the knowledge. Do you need to know every category by heart? Do you need to know that the Singleton is a creational design pattern? No, you can just look it up if you need that information. So if you're trying to solve a problem related to creating, instantiating your object graph, you can consult the creational design patterns. But that's it. You don't need to memorize everything.
Okay, so I believe the next questions are related to specific design patterns. So let's dive right in.
What is the adapter design pattern? So the adapter design pattern is a structural design pattern that allows you to adapt the interface of a component to an interface that a client expects without changing that component. Let's say a client wants to make a request to another component, but that component doesn't have the interface the client wants. You don't want to change the client, and you don't want to change the components as well. So you create an adapter in the middle to translate that communication, to adapt that communication. So the adapter needs to know how to make the request, right? Translate the client's request to the component, and also translate back the result to what the client wants.
That is correct. I have found out that a very simple way to think about these things is with plugs and chargers and electricity. For instance, you have a UK charger for your MacBook. You travel to Greece. Here we have EU plugs. You can't plug your charger into the EU plug. So what do you need? You need an adapter.
Exactly. I have an adapter here that can convert any plug to any plug.
That's a very valuable tool.
Exactly. So the client, in this case, is your machine that you want to charge.
That's it.
So you need this adapter to convert the plug so you can charge the client, the machine.
That's it, basically. Everyone is doing their job, but there is an incompatibility when you connect them. So you want to remove the incompatibility. And how do you do that? Create an adapter.
Exactly. And we can follow the same principle in software. So a quote here, again from Eric Evans in the Domain-Driven Design book. An adapter is a wrapper that allows a client to use a different protocol than that understood by the implementer of the behavior. When a client sends a message to an adapter, it is converted to a semantically equivalent message and sent on to the adaptee. The response is converted and passed back.
That's it.
So that's it. When you have unmatching interfaces, you put an adapter in the middle.
The keyword is convert here. You just need to convert what the client expects with what the server provides.
That's it. So you use an adapter when you want to use a component, but it doesn't expose the interface you want. For example, imagine you have a table view controller that expects to receive an array of view models to render on the screen.
Mm-hmm.
But the service providing the data returns a dictionary.
Right. So here you have clearly an incompatibility between these two data structures.
Yes.
The view controller expects an array, but the service provides a dictionary.
Yes. So you either convert the dictionary to an array of view models in the table view controller, or you make the service convert that data into view models before returning it. But if you do so, either the table view controller will be coupled with the service, or the service will be coupled with the view models. And usually you want services that are not coupled with the UI, with the presentation layer.
Yes. Usually, yes.
And you also don't want your view controllers coupled with a service. So the solution is to put an adapter in between them. The adapter that will convert the request from the table view controller to the service. And when you get a response back from the service, it's going to convert it to what the table view controller expects. And that's it. Then the table view controller and the service are much simpler, maintainable, decoupled, reusable. They are both replaceable and easier to test in isolation.
The equivalent would be to buy a new MacBook in every new country you're going because of the incompatibility with the charger. So you don't want that, right? You just want to buy. Well, yeah. Good for you if you do. What you want is just a small adapter that is going to make your MacBook charge and you can use it with a minimum cost.
That's it. The adapter should be small. Not a lot of logic, just converting the messaging. Next question. What is the composite design pattern? So the composite design pattern is also a structural design pattern. It's related to how you structure your components. So the composite allows you to compose objects through a unified interface. So clients can treat the whole composite as one, even though behind the scenes, you may have a bunch of objects collaborating.
Exactly. So the composite pattern makes heavy use of polymorphism, which allows you basically to create these tree-like structures, which with each node having the same interface.
Yes, because the composite shares the same interface as the objects it composes, which means you can compose composites as well and create a tree structure of your object graph.
Exactly. And if you do so, this thing can scale infinitely, right? Because you never know, like you can have a composite for a reference, which can have another composite for a reference, and this thing can grow infinitely.
Exactly. And just like the adapter pattern, the composite pattern allows you to create open-closed systems. So you can add new features without changing clients, without changing code. You just compose your system differently to get different behaviors. For example, imagine you want to load some data from a remote source, but if it fails, you want to show some cached version of the data. And fetching data from remote can fail for multiple reasons. For example, you may have no network connectivity.
Right.
But you cannot check for network connectivity before performing a request. It's not reliable. The only reliable way to know if you have connectivity with the server or not is to actually perform the request and check if you got a connectivity error back. But if you check if you have connectivity before making a request, Apple documentation, they say, don't do that.
Yeah, they say it.
Don't. It's not reliable. The only reliable way is to perform the request and check the result. If you block a request because you think there's no internet connection, you might be blocking the client from actually making the request. So this logic of trying to load from remote, if the request fails, then look at the cache, can be implemented as a composite. So instead of having if-else everywhere in your code base, you can create a composite that starts with a primary data source that can be the remote, and a fallback data source that can be the cache.
That's it.
So it's going to try to fetch it from the primary source. If it fails, it's going to load it from the cache. And you can just compose this into the composite and pass to the clients. The clients don't need to know about the remote. The clients don't need to know about the cache. The clients don't need to know about the composite. They only talk to the polymorphic interface that hides all those details. The same polymorphic interface that the composite, the remote data source, and the cache data source share, which could be a simple function, load.
You can even go one step further and scale your composition by providing another composite for the fallback strategy when you're loading from the cache. You can say, okay, now I'm loading from the cache as the fallback, but now I have a new strategy. So first, I want to check if I have an in-memory cache, for example, before I hit the store, the persistent store.
Right. So you're composing composites.
You're composing composites. And that's it, what we said in the beginning that of this question, that this thing can scale infinitely. You can compose other composites infinitely.
That's it. You just added a new feature, this in-memory cache lookup, before making a file system request, which can be slow. And you didn't have to change any other part of your system, just the composition root. Thus, you have an open-closed system.
Yes.
You can add this new behavior, the in-memory caching, without changing any of your components. You don't need to change the composite. You don't need to change the remote data source. You don't need to change the persistent cache. You don't need to change the client. You just add a new behavior and you inject it in the composition root.
That's it. Total modularity, total freedom.
That's it. That's the composite pattern. Next question. What is the Decorator design pattern? So the Decorator design pattern is also a structural design pattern. And it offers a way of adding behavior to a component without changing that component.
So you are extending a specific object, not the type of that object. This is very important.
You are decorating an instance, not the class.
Exactly. Right. Because then you would extend the whole class, the whole type. No, here we're talking about one instance.
Exactly. Because if you change your class implementation, every instance is going to get this new behavior. But if you decorate a specific instance and you change the behavior or you add behavior to that instance only without altering the whole class.
It's a very powerful concept because imagine if you didn't do that and you wanted to add some logic in the whole type, all the if statements and the extra state that you might have there, or subclassing for, when you shouldn't be supposed to subclass in the first place.
Mm-hmm.
So decorator pattern just gives you tremendous flexibility and freedom for basically just that one instance.
And this is possible because the decorator shares the same interface with the object it decorates, or the decoratee.
Right.
For example, the decorator pattern is very handy for cross-cutting concerns like logging, debugging, profiling, analytics, tracking, security, authentication, threading. For example, when you're trying to profile how long an operation takes, or you want to track some user actions, like every time you press a button, you want to track that action, all those cross-cutting concerns can be moved to decorators. Thus, you separate the cross-cutting concern from your application logic.
That's it. And that should be your signal, by the way. If you see a class violating the single responsibility principle, then perhaps you can use the decorator pattern and extract any added logic or usage of singletons. As you said, tracking, logging, all these things are usually done with singletons. But why would you pollute your component with these things when you can clearly isolate them in just one instance of this type that you're working with? And that's that's the power of the decorator pattern. It allows you to reinforce the single responsibility principle, maintain open-closed nature in your components.
That's it. Another example. It's very common to see in code bases defensively dispatching to the main queue before performing some UI update.
Yes.
Because you can only perform UI updates in the main thread.
Yes.
And since you don't know if your service will be returning things in the main thread, just defensively always dispatch asynchronous calls in the main thread.
Yes.
The problem is that this is going to make your whole UI code ugly, wrapped in those dispatch queues. It can introduce bugs that is very hard to trace. It can hold your view in memory for longer than it should. It might be dispatching on the main queue, even though it's already in the main queue. So it's doing work it doesn't need to.
Mm-hmm.
Make the user experience worse. So instead, you can move all the dispatch to a centralized place in the composition root.
Yes.
By using decorators.
Exactly. And this is a prime example of what it means to make a change to a single instance rather than a whole class of objects, the whole type, right? Because imagine you have a table view controller and you are fetching something and you want to update you want to dispatch in the main queue. Now that's dispatching logic based on the server, right? So why would you have that in a UI that supposedly is reusable and perhaps it doesn't need that? So what you can do is whenever you need that, you can wrap it in a decorator and just use it for the case at hand.
That's it. So you move the dispatch to a component that knows it needs to dispatch.
That's it.
And that's not in the network client.
No.
Ideally, move it to a decorator in the composition root. Thus, all your components are much more testable as well. Thus, you don't need to be concerned about threading when you're testing your UI. You're concerned about threading when you're testing threading code in the composition root. So next question. What is the Facade design pattern?
Okay. The Facade is a structural design pattern that provides a unified interface to a set of interfaces in a subsystem.
So when you have a system that is quite complex to interact with,
yes,
you can create a facade to simplify the communication.
That's it.
For example, a system that exposes too many interfaces or components that need to work in a very specific way for things to work correctly. If you move this responsibility to the clients, most likely they're going to get this wrong and get bad results. Thus, you move all this complexity to a simple interface where the clients can perform simple operations and get what they want. So you hide the complexity of a complex system in a simple unified interface.
That's it. The keyword here is hide. You're hiding all the complex things that your client does not need. Your client will need just probably a single interface. So you create this abstraction, in a sense, with a single interface, hiding all the complexity from your clients.
For example, if you ever interacted with core data, you know how hard it is to instantiate the core data stack correctly, with the right hierarchy, passing the right migration details, manage data model, and etc. It's a complex stack to instantiate and interact with. Thus, Apple provides us a bunch of facades to deal with that complexity. For example, nowadays we have the NS persistent container for instantiating a pretty default stack for core data, which solves probably 90% of the use cases. You can still go back to the old ways of instantiating all the object graph yourself and creating the context hierarchy as well. You can still do that. But you have this facade that drastically simplifies the instantiation and management of your core data stack, which means most apps will get a correct behavior, the behavior they expect. Because previously, when you had to create the whole stack by hand, a lot of apps would end up with inconsistent data just because they were doing something wrong in the composition, in the setup.
There are more APIs exposed, thus there is a higher probability of using wrong those APIs.
Yeah.
So the facade solves it partially because you don't have all these APIs to interact with. You just have one API or two, depending the case.
Yeah, depending on the use case, you literally just pass your data model name and that's it. You pass a string and you're done.
Yes.
So a facade is a simplified interface to interact with a complex system. Another example in core data is the persistent coordinator. So from the Apple docs, the persistent store coordinator is designed to present a facade to the managed object contexts such that a group of persistent stores appears as an aggregate store. That's it.
There you have it.
So next question. What is the strategy design pattern?
The strategy design pattern is a behavioral design pattern, and it defines a family of algorithms, encapsulating each one of them and using them interchangeably.
So it hides the specific algorithms from the clients.
Yes, exactly.
So let's say you have multiple ways of performing an operation, and depending on some state, on some data, some conditions, you want to use one or the other. But you don't want to move this responsibility to the client. You don't want the client choosing which algorithm to use.
Yes.
Thus, you use the strategy design pattern to decouple the client from a family of strategies or algorithms.
As the composite design pattern, it relies heavily in polymorphism, and that's the basic mechanism for encapsulating these algorithms or strategies into single components and using them interchangeably later on.
Exactly. So you can reuse the strategies in different clients instead of duplicating a lot of if, else, or duplicating the conditions that's going to make you choose one algorithm over the other.
Yes.
For example, let's say you want to fetch some data in your iOS app, but depending on the connectivity state, for example, if it's Wi-Fi or 4G, you want to load the data from different sources or from different endpoints. Because if you are on Wi-Fi, you're happy to download high quality images, but if you are on 4G, you want lower quality images to save data. instead of having this if-else logic in the client that's going to make the request, you create a polymorphic interface that your strategy is going to implement. And then you can have a Wi-Fi strategy, a 4G strategy. And this is going to be decided in the strategy layer, not by the client.
Right.
Thus, you decouple this decision from the client, which simplifies the client and allows you to add new strategies in the future. For example, a 3G strategy, a 5G strategy, and etc. without changing the client or the polymorphic interface. Because the interface the client is going to depend on should not leak details about specific or concrete strategies. So you can also use the strategy pattern to decide between algorithms depending on low battery, or if the battery is fully charged, if you have space on disk or not, or if you want to perform different kind of logic depending on some customer settings. Like if the user requests you to save data, you can use a strategy that's going to request less data less often, and so on. And you decouple your application from those device details like battery state, connectivity state. Thus your code is much cleaner, easier to test.
Yes, exactly. Your code is conforming to the solid principles. You create single responsibility, self-contained components, your clients, without having this knowledge of the whatever strategy, whatever algorithm, whatever logic you have, you want to encapsulate. And not just that, but you can extend that logic. You can add more and more and more in the future without having to change the code that you have already in your clients. So it's the decoupling there is something special indeed, because it allows you to branch out in many different logic forms, basically your application, and you can just add the new branch of logic every single time rather than going back and changing stuff. So, I mean, just all the cases that you mentioned are everyday use cases. If you want to check the battery, if you want to check the connectivity, signal, all these things. Now, imagine how would you do these things if you weren't to use the strategy pattern or a similar pattern.
If else everywhere.
Exactly. Like we're talking about thousands of lines probably in your view controllers, and with if else and flags, booleans, properties, state.
Yeah, it's going to make your code very hard to test as well, because you need to set the system in a specific state.
That's it.
Simulate that state at the UI level.
Yes, at the UI level.
Or at any other level that is not supposed to do this kind of logic. So the strategy pattern makes your system open, closed.
Yes.
It's open for extension and closed for modification, which means you can add new behavior or even remove behavior without having to change your system. You just compose it differently.
That's it.
That's it. Next question. What is the chain of responsibility design pattern?
So the chain of responsibility is a behavioral design pattern which avoids coupling between the sender of a request and the receiver of a request.
So the sender and the handler.
The sender and the handler, that's correct, by providing more than one handlers.
Right. But the client that makes the request don't know that there's more than one handler.
That's exactly right.
So it gives a chance for more than one handler to handle that request.
That's it. And the handlers are decoupled from the requesters, and vice versa, of course.
So it creates a chain of objects. And why is it called a chain? Because it's very similar to a linked list.
Yes, exactly.
Because a handler has a reference to the next handler. And the next handler has a reference only to the next handler, and to the next handler, and to the next handler.
That's it.
So if anyone in the responder chain cannot handle the request, it asks the next responder to handle it. And if the other responder cannot handle it, it keeps asking down the chain until you find a responder that can handle the request, and then it stops.
Yes. And as iOS developers, we are familiar with this concept, even if we do know that it's the chain of responsibility pattern or not.
Yes.
With UI responder.
So the UI responder is an implementation of the chain responsibility design pattern.
Exactly. We have a hierarchy of components from UI application to UI view to UI view controller, all implementing the UI responder type.
For example, iOS apps receives and handles touch events or motion events using a chain of responder objects.
Mm-hmm.
In a responder object is any instance of subclasses of the UI responder abstract class. As you said, common subclasses of UI responder, UI view, which includes UI window, you have UI view controllers, UI application, the application delegate, and etc.
That's it.
So when your app receives a touch or a motion event, it's going to delegate that to the first responder.
Yes.
And if it cannot handle it, it's going to ask the next responder. And if this responder cannot handle the request, it's going to ask the next one and the next one and the next one until it finds someone that can handle the event. So that's the chain responsibility design pattern and how it's implemented in iOS with UIKit.
That's it.
Next, what is the observer design pattern?
The observer pattern is a behavioral design pattern defining a one-to-many dependency between objects, where one object changes its state, then all other dependency objects are notified of this change.
Right, so you have an object that can be observed, and you have observers that can subscribe to state changes.
Yes, keyword subscribe. That's exactly right. They are saying basically, I want to listen for changes, or I want to be notified of any changes on specific properties of a specific object.
And that's a very popular design pattern in iOS as well.
Exactly.
For a long time, we have, for example, key value observing, or KVO, where you can subscribe or observe state changes for properties of objects. So every time that property or that state changes, you can receive a notification. And as you said, it's a one-to-many relationship. You can have many observers for the same observable object.
Yes.
And more recently, with Combine, we also have other implementations of the observer pattern. There is even an observable object protocol for observing changes in an object. So in SwiftUI, when you bind it with an observable object, every time there's a change in the object, the view will re-render itself, for example. So that's it. Other implementations you can also find with RX Swift and other popular frameworks, where you can observe state changes and react to it.
Yes, that's exactly right.
So next question. What is the Singleton design pattern? The most popular one.
Probably, yes. And the Singleton design pattern is a creational design pattern that ensures a class has only a single instance, and it provides a point of access to that instance.
Right. And that shared instance should not be accessed from anywhere in your app. If you do, that's an anti-pattern. Ideally, you should inject instances or dependencies into your components instead of accessing global instances directly. Thus, you don't couple your system with a specific instance. You can replace it and make your system more open-closed. So there's nothing wrong with the Singleton pattern, but any of those patterns, if you abuse it, is going to give you negative returns.
Right.
So that's it. When should you use the Singleton pattern? When you want to guarantee there's only one instance, not for convenience of accessing that instance.
Yes.
And as a framework creator, like Apple with your session, you can give a convenience shared instance that your clients can use out of the box. But that doesn't mean that you, as a consumer of the API, should access the shared instance from anywhere in your app. You can also inject that instance into your components because it's a dependency. And dependencies should be explicit.
Yes.
To improve maintainability to make your system open-closed and easier to test and maintain.
If you want to know more about dependencies, you should check out our dependency injection podcast.
That's it. In the DI podcast, we dive deep into dependency injection and patterns you can apply to manage your dependencies effectively. Next question. What is the builder pattern? Another popular pattern in iOS.
Right. And the builder design pattern is another creational design pattern.
It creates or builds things.
Right, exactly. Allowing you to create complex components, but by hiding all the complexity.
Right. So when you have a component that's hard to create, you can use the builder pattern to make it easier for clients to create that component.
That's it.
For example, creating a URL is quite complex. There's a bunch of rules in the URL standards.
Right.
And complying to all those rules, it's very hard to do. There's encoding rules, length rules, protocols, domains, paths, and etc. So to guarantee that you create a URL correctly with all the properties you want, you can use URL components, which is an implementation of the builder pattern for creating URLs.
Yes.
So you instantiate a URL component and you can set query parameters, domains, protocols, and ask the URL components to create the URL for you. So then you're only concerned with the data you want to pass to create the URL.
Yes.
And the URL components, the builder, hides all the complexity of validating and generating a standardized URL.
That's it.
And you can do this step by step. First, set the query parameters. Then you set the protocol. And that's it. So it gives you a step-by-step way. It simplifies the process of creating complex components. Next question. Should I learn all design patterns by heart? Should I know all of them? Should I memorize all design patterns?
I think we established that already. No, certainly you don't need to memorize the whole catalog. At the same time, you should be familiar with some of the most important structural or behavioral.
So you don't need to memorize everything, but at least the main ones. Understand them. So when you're solving a problem, get the catalog and check if any of those patterns can help you solve your problems.
Yes, exactly. And as you progress in your career and you're going to be exposed to more and more problems, you're just going to stumble upon more and more design patterns.
So that's it for today. If you want to learn more, go to academy.essentialdeveloper.com.
Let us know your thoughts, your feedback, and your comments, and we'll see you again next time. Bye, y'all.
See ya.